Hello everyone. Welcome to lesson 5 of this series on advanced functions for 12th grade in Ontario. Today we're going to be learning about transformations of polynomial functions. This is a bit more of a complicated topic, so make sure you pay close attention as this is crucial for any test or exam on this class and also has a lot of later applications later in your studies. But to get started, let's just start with a simple conversion of equations. So when we have y equals x to the power of n, that will give us y equals a, parenthesis b, and then x minus h, close both to the power of n plus k. This is the equation after the transformations are done. So there's also a way for us to just convert a specific coordinate. This is very useful for graphical representations. So if we get x and y, that'll convert to x over b plus h and ay plus k. So this is our new x and this is our new y. And this is a little bit of a complicated formula. Unfortunately, there's no simple way of remembering it, so you just got to try your best for that. But now let's go into each and every single variable here and what they represent. So h is for horizontal, misspelled horizontal there, horizontal translations. K is for vertical I also misspelled that one. Translations. A is for vertical stretch / compression. And it also does vertical reflections. B is for horizontal stretch / compressions and reflections. So those are the four that you need to know. So let's get into some examples to kind of understand. So we'll first start off with our translations. These are the easiest ones. You don't necessarily need to do a table of value to graph them out, as it's simply just moving the same equation upwards. So to start off, if h is bigger than 0, this is a translation to the right. If h is smaller than 0, it's to the left. This just means if it's positive, it's to the right. If it's negative, it's to the left. So let's give an example here. So let's say we have the equation, a simple equation. This is supposed to be our y equals x to the power of 3. And so we have a translation to the right. It would look, let's say, we'll do 3 to the right. So that's y equals x minus 3 to the power of 3. That will be 1, 2, 3, just like that. And then it'll follow the same shape down there. And you may be wondering, I said positive is to the right. Why is it negative right there? Well, that is our most common mistake. Let's go back to the initial thing, to the initial equation here. We see this is a negative. And so if we have x minus 3, that means 3 is positive. Right? Because we're looking just at the 3. But if we have x plus 3, that means we really have x minus 3, which makes it negative. So that's what's important to remember about this one. But let's just keep going. And let's say, for example, we now have y equals, and then x plus, let's say, 2 to the power of 3. We're going to do 2 jumps, 1, 2, put our origin back, and we'll draw it exactly how we drew it before. If you want a very accurate drawing, I recommend using a table of contents, but just this is a simple representation. And now for our vertical translations, we have that if k is bigger than 0, it's upwards. And if k is smaller than 0, it's now downwards. This one In our equation, it's just plus k, and so it's very straightforward. So let's just draw out our original function just like that. So that we'll say is y equals x to the power of 3. Our plus we will have right here, so we'll do 1, 2, 3, and we'll have our origin there, and it'll go up like this. So we'll say this is y equals x plus 3 plus 3. And then at the negative, let's just have our, let's say negative 2, so 1, 2. So going right there, and we have our simple graph going like that. This is not the best drawing. I can try to clean it up for us, but I think that this just goes to show how simple a translation can be, and that it doesn't take a table of contents to understand, because we can just understand it graphically. But moving on to what is more complicated, and this requires a table of contents, will be our A. And so our A, again, is our vertical stretch, compression, reflection. But to start off, we will start with just our stretch and compression, and we'll go into reflections a bit later. And so for our vertical stretch and compression, let's bring back the equation for the coordinates we said. So remember that x, y now gives x over b plus h and our ay plus k. And since now we're just looking at a, it just becomes x. Y just becomes x and then a y. Just like that. And so we're going to draw 3 separate ones. So first we're going to start with y equals x to the power of 3. That is a pretty simple table of contents for us. So we have x, y. So let's say negative 2, negative 1, 1, 2. That just gives us negative 8, negative 1, 0, 1, 8. And next up, we're going to draw, this is going to be y equals 3x cubed. And so that means a is equal to 3 here. And so we're going to have our table of contents for that, x, y, and let's just put negative 2, negative 1, 0, 1, 2, and that's now going to become negative 24, negative 3, 0, 3, 24, and finally we're going to have y equals, we'll say 1/2 x cubed, and so that a is now 1 over 2, and so, oh sorry, there's a 3 there. Let's just put that there to make it more simple. And now we're going to have x, and then we'll put 1 over 2y. So this is our y initially that we had before. So we're just going to keep x the same, and y, we're now going to do half of 8, which is 4, and then negative 1 over 2, 0, and then 1 over 2, and then 4. And so when we go to draw that, I'm not going to draw them fully just now, but I'll draw some representations. So this one here is the one that we'll do in blue. And so in blue, we have, it'll get a little bit tighter in here. Yeah, just like that. And then we'll draw when a is 1/2 in red, and that makes it a little bit wider, just like that. And so that just goes to show the ability of A and how it influences our graph. So now we're going to go ahead and do the same thing for B. And so B, again, is our horizontal stretch and compression. And again, we'll bring back the equation. So x, y leads to x over B plus h, yeah, and then ay plus k, just like that. And so now that we're only focusing on B, let's just simplify it to get rid of the ones we don't. So now x over B and then y, just like that. And so we'll start again with our y equals x over 3, which gives us the table to start off with, which is just x, y, and so we'll do negative 2, 1, 0, 1, 2. And this one here is negative 8, negative 1, 0, 1, 8. And then now for here, we'll do x over, or we'll do y, let's write the equation first, y equals, and let's just say 1 over 3x and the whole thing cubed. Because again, our b is inside the parenthesis of the exponent. And so that gives us x over 3. It is x over h, which means it's x over 1/3, which means it's actually 3x. So we can do that one first, and so that just gives us negative 6, negative 3, 0, 3, 6. And then these are just the same. Just like that. And then we'll do our separate one over here, and we'll have y equals, and then we'll do, how about 3x cubed to keep it simple. And that'll give us here x over 3, and then y. And so that gives us negative 2 over 3, negative 1 over 3, 0, 1 over 3, and then 2 over 3. And we just keep the negative 8, negative 1, 0, 1, 8. And so those are a table of contents for them. And just to see how it graphically changes things, let's just look at, let me just draw our initial function on here. Just like that. And then our first one, I'll draw in blue. And that'll give us a bit wider, just like that. Because we can see we're elongating it horizontally. And then for our red, I'll do this one over here in red. And so that's the one that now tightens it up a little and brings it closer to the y-axis, just like that. And so hopefully you were able to visualize how the A and the B have now affected the graphs. We can see it's the reverse. And so a greater B will make it more tight, and a wider or a smaller B will make it wider. But let's move on to reflections. Reflections are quite simple as the name intends it. And it's simply that we can use our our x, y, that leads us to, and then x over b plus h, and our a, y plus k. And we'll just keep the a in and the b because that's all we really want. And so it gives us x over b, and then a, y, just like that. And so we can see if one of them is negative, let's say for this one, b is equal to negative 1, in our table of contents, which was initially, we'll say for x over 3 again, negative 2, 1, 0, 1, 2, negative 8, negative 1, 0, 1, 8. We can see if b is now negative 1, that will give us negative x over y. So now we'll have 2, 1, 0, negative 1, 2. And then here we have negative 8, negative 1, 0, 1, 8. Just like that. We can see that this would in turn, what was initially a simple graph like this, is now a graph like this. Because on our x-axis, our negatives have now become our positives. And the same thing applies for A. We can see that if instead of x being negative, we decided to make y negative, it gives us negative 1. So here we'll say A is negative 1. We will now get negative 2, 1, 0, 1, 2, 8, 1, 0, negative 1, and negative 8. And we can see it gives us a very, actually identical function on this case. Not always the case, but for this case it was identical as if b was negative 1. But we can see it's just flipped it along the x-axis. Just like that. Whereas the b flips it along the y-axis. But that's it for this video. If you have any questions, feel free to leave them in the comments. I'm happy to answer anything. But other than that, I hope you have a great day, and I'll see you in the next video.